Now, let's look at an example on theorem number 1. Here we are given that EH is a diameter, and we are also given that OF bisects EG. When they say OF bisects EG, it means that it cuts EG into 2 equal halves. So it means that is why you see that it means that EF is equals to FG. That's what we are told, that OF bisects EG. By bisecting EG, it means that EF is equals to FG. Now, we are told to find E angle OG. We are told to find E angle OG. We are told to find this angle there. Now let's find this angle. The first thing that we are going to do, we are going to say OF is perpendicular to EG. Reason? Line from center, I can use that, line from center to the mid point of chord. I want us to get used to saying which chord are we talking about, because there will be many chords the next time we're doing this. So line from center to the midpoint of chord EG. Now, so it means that this is perpendicular like that. Therefore, triangle OEF and triangle OFG are congruent. By congruent, it means that they are the same shape, they are the same in all respect. Now, OFG and OEF, triangle OEF and triangle OFG are congruent, and they are right-angled triangles. Now, we can find this angle there. Since we are given that EH, we were also given that EH is equals to 120, is equals to 120 units. And we're also given that FG is equals to 50 units. You will see that sometimes trigonometry does not work with geometry problems. We are going to have a problem of that kind where your trigonometry does not work in a geometric problem. But in this particular problem, therefore trigonometry is going to work here. Now, we can find this angle there. Since we know that OG is equals to half EH. Why? OG is the radius, and we've said it that the radius is half of the diameter. The radius is half of the diameter. Therefore, OG is equals to half EH. Now, we can find OG, which is 60 units. Now we've got 60 units there, we've got 50 units there. Now, we can find this angle since we've got the hypotenuse and we have the base side. Therefore, we can use adjacent over hypotenuse, which is your saw ka, to, wa. Cos is adjacent over hypotenuse. Therefore, we're going to say cos of O angle GF. Cos of this angle. Cos of this angle. And this angle is O angle GF. That is why I've got O angle GF. Therefore, cos of this angle is equals to adjacent over hypotenuse. Our hypotenuse is that. Our adjacent, obviously, it is 50 over 60. Now, obviously here, we are gonna use our calculator to find O angle GF using second function. In our calculator, second function, in our calculator, 50 over 60. Now, the answer is 33.557 degrees to 3 decimal place. Now, we now have this angle there, and we are looking for this angle there. You must not forget that we are looking for this angle there. Now, we got this angle here, and we can just conclude to say that O angle GF is equals to O angle EF equals to 33.557 degrees. Therefore, this angle is equals to this angle there. Why are they equal to? It is because the reason for us to say this, the reason is that triangle OEG is an isosceles triangle, is isosceles triangle, meaning that OE is equals to OG. That's the reason. OEG is an isosceles triangle. Base angle of an isosceles triangle are equal. That is why these two angles, this angle is equal to these angles, because they are base angles of an isosceles triangle OEG. Therefore, we can add this plus this plus this. We are going to say E angle OG plus O angle GF plus O angle EF is equals to 180 degrees. Reason, sum of angles on triangle OEG. So this angle plus this angle plus this angle is equal to 180 degrees. We know that the sum of angles on a triangle add up to 180 degrees. Now, we want E angle OG. We know E angle GF, O angle GF and O angle EF. So E angle OG plus, obviously here they are equal, these two. Then we are going to have 2 O angle GF is equal to 180 degrees, because these two are equal. These two are equal. So that is why I put, for this, I put O angle GF for this. Therefore, that is why I get 2 O angle GF equals 280 degrees. Now, E angle OG is equal to 180 degrees minus 2 O angle GF, which is equal to 180 degrees minus 2 times that angle, which is 33.557 degrees, which is equals to 112,885 degrees, of which is this angle that they were looking for there. Now, let's look at an example on theorem number 2. Here we are given that IJK are points on the circle, and we are also given that I angle OJ, which is this angle, is 110 degrees. And we are also given that K angle IO is 32 degrees. We are told to find K angle JO, which is this angle there. We are told to find this angle there, which is K angle JO. Now, we start by saying that O angle J I, O angle J I, which is this angle there, is equals to J angle I O. Therefore, this angle is equals to that angle there. That's what we mean here. Therefore, reason for us saying that this angle is equals to that, which is O angle J I, which is equals to J angle I O. This angle is equals to that angle, where we have triangle OIJ is isos. Since OI is equals to OJ, radi. We can say radi if we want, or base angles of an isosceles triangle, or base angles of an isosceles triangle are equal. Now, O angle JI plus J angle I O plus I angle O J is equal to 180 degrees. Reason? Sum of angles on triangle OIJ. Sum of angles on triangle OIJ. Now, we know that we are looking for O angle JI. Now, here and here, they are equal. Therefore, we're going to have 2 O angle JI plus I angle OJ, which is equals to 280 degrees. Here, I substituted him since they are equal. So where I see that, here I put him. That is why we have 2 O angle JI plus I angle OJ equals 280 degrees. Now, therefore, 2 O angle JI is equal to 280 minus I angle OJ, which is equals to 180 degrees minus I angle OJ is 110, which is 70 degrees. Since we are looking for O angle JI, we divide by 2, divide by 2. Therefore, O angle JI is equals to 35 degrees. Therefore, since O angle JI is equals to 35, so it means that here we've got 35 degrees. Since O angle JI is equals to J angle IO, so it means that also here we've got 35 degrees. Therefore, since we know that I angle OJ, which is this, is equals to 2 times I angle KJ, risen angle at center is twice angle at circumference. Now, I angle OJ is 110, which is equals to 2 I angle KJ. We can find this angle by dividing by 2, dividing by 2. Then we've got I angle KJ is equals to 55 degrees. Now, we now have this angle there, which is 55 degrees. And we were told to find K angle JO, K angle JO. Now we can find K angle JO. And this is how we find K angle JO. We're going to say this plus this, which is one angle. This plus that, which is another angle. Plus that, a sum of angles on a triangle. Now, okay, let's start with K angle IO plus O angle IJ plus I angle JO plus O angle JK plus J angle KI is equal to 180 degrees. So this angle plus this angle plus this angle plus this angle plus that angle is equal to 180 degrees. Reason, I'm going to write the reason up here. Sum of angles on which triangle? Triangle IKJ. IKJ. Now, we do have K angle IO, K angle IO, which is 32 degrees, plus we do have O angle IJ, which is 35 degrees, plus we do have I angle JO, I angle JO, which is plus 35 degrees. We do have O angle JK. That's what we are looking for. O angle JK plus J angle KI, which is 55 degrees, equals to 180 degrees. Now, this plus this plus this plus that is 157 degrees plus O angle JK equals 280 degrees. Now we take this to the other side, then we can find what we are looking for. Where we're going to say O angle JK, which is equal to 280 degrees minus 157 degrees, which is equal to 23 degrees. And O angle JK, we can name it as K angle JO. O angle JK, we can name it as K angle JO. So this and that is one and the same angle. Now, let's look at the example on theorem number 3. In these examples, we are trying to make sure that you get used to the theorems. Now, in the next part, which is part 3, there we are going to be looking at exam question papers, and it's going to be easy for us to solve these problems because already we are used to theorems. Now let's look at the example on theorem number 3. The example on theorem number 3, we are told that O is the center of the circle RST. O is the center of the circle RST with diameter RT. Now, we know that this is diameter. We are told that with diameter RT. Now we are told that determine with reasons the R angle ST, which is R angle ST. They also want us to find B R angle TS, R angle TS, which is that angle there. They also want us to find T angle RS, which is this angle there. So it means that we just need to solve for this triangle for the angles. Now, for us to find R angle ST, since we know that RT is a diameter and S is at the circumference, so it means that T angle S R is equals to 90 degrees. Reason? Since we know that this is a diameter, the theorem number 3, tells us that an angle subtended by a diameter is 90 degrees. Therefore, here we know that angle subtended by diameter, we must tell which diameter is that. Diameter RT. Angle subtended by diameter RT is equals to 90 degrees. Now we got R angle ST using theorem number 3. Now we want to find R angle TS, and for us to find R angle TS, which is 4x there, we know that this is 90 degrees. Therefore, it means that when we add this plus this, we must also get 90 degrees, because sum of angles on a triangle is 180 degrees. We know that this is 90 degrees. We've just got it. We put it there. Now, if this is 90 degrees, it means that this plus that must be equals to 90 for the sum of these angles to be 180 degrees. Therefore, R angle T S plus T angle R S is equals to 90 degrees. Now, since this is what we have, which is we can say is the sum of angles on triangle RTS. Obviously, we know that it is the sum because we know that this is 90 degrees. Or we can just say complementary angles. Let's just say complementary angles. Which they add up to 90 degrees. Now, R angle TS is 4x plus, which is that, R angle TS, and we have T angle RS, which is 2x, which is equals to 90 degrees. Now here we're going to have now here we're going to have 6x is equals to 90 degrees. Dividing by 6, we get x is equals to 15 degrees. Now, since we got our x, we can find R angle TS. R angle TS is equals to 4x, because that's the angle R angle TS, which is equals to 4x. But we do have the value of x, therefore it means that here we're going to have 4 times 15 degrees, and then 4 times 15 degrees, which is 60 degrees, our R angle TS. Now, we can also find our T angle RS, which is what we are looking for. T angle RS is equals to 2x, which is equals to 2 times 15 degrees, which is equals to 30 degrees. If we wanted for us to find T angle RS, we could have just said T angle RS is equals to 90, which is this angle, minus that angle there. We're going to get this angle there. Therefore, 90 minus 60 degrees, which is also equals to 30 degrees. However we prefer, you can use that, or you can use that. Where T angle RS is equals to 90 minus this angle, this minus that, we're going to get this angle there, which is 30 degrees.